Hello and welcome to this video. How are you today? I hope you are all doing great. Stay safe and healthy. So we shall start our lesson. So our lesson for today is the limit of a function. So our objectives: at the end of this lesson, the learners illustrate the limit of a function using a table of values and the graph of the function. So we will now have our activity. So think of any situation or idea that shows limit. So I'll give you 1 minute to think of any idea or situation that shows limit. Your timer starts now. Okay, so the time is up. So let us check if your idea is similar to my idea. The first example is the 20 km per hour speed limit. This road sign is usually found on the road fronting school to avoid road accidents on the crossing pedestrian, especially you learners. The second example is the temperature. The normal body temperature is 37.5 degrees Celsius. Exceeding that temperature means you have a fever. The next example is the social distancing set by the Interagency Task Force for the Emerging Infectious Disease in the implementation of the general community quarantine in the Philippines. This limits the people from higher possibility of getting the coronavirus or the COVID-19. Limits are the backbone of calculus, and calculus is called the mathematics of change. The study of limits is necessary in studying change in great detail. The evaluation of a particular limit is what underlies the formulation of the derivative and the integral of a function. So let's have a real-life situation of how limits look like. Imagine that you have a relative coming from Manila. The IATF COVID-19 protocol states that your relative must be quarantined in a facility. So you would want to see your beloved relative, but you are not allowed to see him or her in person. So what you can do is watch him or her from afar, but you cannot be as close as possible. So this is how it is with limits of functions. We will consider functions of a single variable and study the behavior of the function as its variable approaches a particular value. So in this case, a constant. The variable can only take values very, very close to the constant, but it cannot equal the constant itself. However, the limit will be able to describe clearly what is happening to the function near that constant. So let's have the clear definition of the limit. So consider a function f of a single variable x. Consider a constant c, which the variable x will approach. C may or may not be in the domain of the function. The limit to be denoted by L is the unique real value that the function will approach as x approaches c. In symbols, we will write this process as, or this is read as the limit of f of x as x approaches c is L. So let's have a recall first of what does it mean. What does it mean by approaching to a number C? So we have a number line and C on it. So it means approaching number C can be from the left or from the right. So what are the real numbers approaching 2? So we have the number line. So this is the numbers approaching to 2. From the left of 2, we have 0, 1, 1.5, 1.75, 1.9, 1.99, and so on. And numbers from the right of 2 are 4, 3, 2.5, 2.25, 2.1, 2.01, 2.001, and so on. So that is approaching, getting closer to a number. Now let's try to find the limit of a function using the table of values. So consider the limit of the quantity 1 plus 3x as x approaches to 2. So from the left of 2, we have these values. Take note that these values may be different. You may select any values that are approaching to 2 and try to evaluate the function using these values. So how to get the values of the function? Just simply put each values of x, substitute it to our function, and solve for and simplify. So you may use the calculators to easily get the values of the function, or you may use the Excel to get all the values needed for these values of x as x approaches to 2. So our values are this one. So take note that the values are going to or approaching to, the values of our function is approaching to the value of 7. Now let's try to take the values, the table of values for uh, coming from the right of 2. So we have these values 3 up to 2.001, and we get our values for this one. And you can see that the values of our function is approaching to 7. So therefore, we can say that limit of the quantity 1 plus 3x as x approaches to 2 is 7. Okay, let's proceed with another illustration. So investigate the limit of the function x squared plus 1 as x approaches to negative 1 by constructing table of values. So in this case, c is equal to negative 1 and our function is x squared plus 1. So from the left of 1, we have this table. And from the right of negative 1, we can have this table of values. So as you can see, in this table from the left of negative 1, so we have negative 1.5 up to negative 1.0001. So the values is going to 2. And from the right of negative 1, we have negative 0.5 to negative 0.9999. And as you can see, the values of our function from the right of negative 1 approaches to 1.99999. If we continue this one as close as to negative 1, the value of our function is 2. So therefore, we can say that the limit of the quantity x squared plus 1 as x approaches negative 1 is equal to 2. And for example number 3, investigate the limit of the absolute value of x as x approaches 0 through table of values. So from left of 0, we can have this table of values. And from the right of 0, we can have this table of values. So what will be the limit of our function based on the table? Okay, so the limit of the function is equal to 0. So therefore, the limit of the absolute value of x as x approaches to 0 is 0. For our illustration number 4, so investigate the limit of x squared minus 5x plus 4 over x minus 1 by constructing a table of values. So here, our c is equal to 1 and our function is equal to x squared minus 5x plus 4 over x minus 1. Take note that 1 is not included in the domain of f of x. Why? Because if we are going to substitute the value of the value c in our function becomes undefined. Okay, so this is not a problem since in the beginning of our lesson, it states that c may or may not be uh, included or may or may not be part of the domain of the function. So this is not a problem. So from the right of 1, so we have this table of values. From the left of 1, we have these values. Okay, so from the right of 1, we have 1.5 up to 1. And from the left of 1, we have 0.5 to 0.9999. So as you can see, the values of our function is approaching to the number c. So therefore, we can say that the limit of x squared minus 5x plus 4 all over x minus 1 as x approaches 1 is equal to negative 3. So going to our last example, investigate through table of values the limit of the function as x approaches 4 if we have these conditions. If x is less than 4, or we'll use the function x plus 1. And if x is greater than or equal to 4, then we will use the function the square of the quantity x minus 4 plus 3. So from the left of 4, so the values left of 4 are less than 4. So we will use the function f of x is equal to x plus 1. So here is our table of values. And from the right of 4, so will use the function f of x is equal to the square of the quantity x minus 4 plus 3. And we will get this table of values. As you can see, the values of f of x are different or approaching to a different value. So here it is approaching to 5 and here it is approaching to 3. So therefore, they are not equal. They are not approaching to the same value. So it means that the limit of the function does not exist, or limit of the function as x approaches 4, DNE. DNE means does not exist. Now let's try to look at the graph of the function. So the first example we had earlier is y is equal to 1 plus 3x. So consider again f of x is equal to 1 plus 3x. Its graph is the straight line with the slope 3 and intercepts at the point 0, 1 and negative 1/3, 0. Look at the graph in the vicinity of x is equal to 2. So here is the graph. So you can easily see the points from the table of the values in table of values above. Okay, so we have 1 and 4. So 1 and 4 is 1. 1.4 and 5.2. 1.4 and 5.2. 1.7 and 6.1. And as it approaches to 2, the value is 7. So the limit of the function x plus 3x as x approaches 2 is equal to 7. Consider again the graph of y is equal to x squared plus 2. So here the limit is approaching to, or the x is approaching to negative 1. So the value going to negative 1, the value of our function y is going to the value of 2. Okay, another example, the graph of the absolute value of x. So the limit of the function, the absolute value of x, as x approaches to 0 is 0. So and let's have another example of a graph of the function of this function. So this is our graph of the function. X plus 1, it will be a line, but since we limit the domain of our function, x is less than negative 4, so it will be a hollow. So let's recall the lessons in junior high school. What does it mean by a hollow and a shaded part? So a hollow means if the solution is not included, and if it is shaded part, it is included or have a greater than or equal sign. So here, less than 4, the value is 5. And if greater than or equal to, from the right of 4, the value is 3. So therefore, the limit of the function does not exist as x approaches 3. Okay, so we have the last graph. So here, as x approaches to 1, okay, as x approaches to 1, the value is negative 3. But in this case, the intersection or the point 1, negative 3 is a hollow part. It means that this is not included in the solution of the function, but the limit of that function as it approaches to uh, 1 is equal to negative 3. So let's have an exercises. So we have two exercises. So you may replay this video to copy more of the exercises. Thank you and see you in the next video.